Welcome to this mini session on how to solder copper tubing safely. So today what we're going to be doing is we have two pieces of copper and we're going to be joining them together using a coupling and the soldering technique with a torch. So as we think about how to accomplish this task safely, let's talk about the basics of soldering, which should help us think through the different precautions that we got to take. So with soldering, we're going to use an open flame torch, which is going to heat up the copper. It's going to heat the copper up enough that solder can melt and flow into the fitting. So we need to make sure that we're not going to light the space on fire. We got to think about how the heat is going to travel down the pipe and it's going to be in the area, and that could cause ignition or things to melt. We got to think about the fumes that are generated from soldering. Flux and the solder are going to melt. And if different things in the space would start to melt and off-gas something, we need to be thinking about that. So let's first talk about how we're going to protect the space from the open flame and the heat that's generated. So everything sitting on this table is on top of a welding blanket. This is great. That can be used to put over top of the carpet, surround yourself so sparks can't fly, different things like that. And that's a great tool. This bucket here of water and wet rags, that's an industry standard. Again, protecting components. Think about when the pipe's connected, you might have fittings, valves, components, different things going down the line, and that heat's going to travel. So you can use a wet rag to protect these different components. A vacuum cleaner, very basic but crucial tool. You can sweep up the floor. If you're in a basement, you can be getting rid of cobwebs, different things that can ignite. So just really think, whatever space you're working in, think what potentially here can catch fire and protect the area. So another thing to be thinking about is how we're going to protect our lungs. First, we got to be thinking, is the space super small, which is going to equal less oxygen? Maybe we need to find a way to get oxygen in. Maybe we need to open a window. Maybe we need to have a box fan, some type of portable fan, moving air, the fumes away from us. Maybe we need to actually have an actual dedicated fume extractor. Maybe we need to have a respirator. We always want to have a fire extinguisher ready, because no matter how skilled we are and prepared we may be, accidents can happen. So just be ready for that. So we talked about that. Let's talk about the actual preparation of the copper before we head outside and actually complete this soldering project. So, and real quick, I forgot about this putty. This is like a heat compound putty, and you can put that on these valves and components, and it will just help absorb heat. So really, as we think about this, to help kind of get the wheels turning more, if we were at home and we grabbed a super hot pipe, that pipe would burn us. And the longer we held on to that pipe, the worse the burn would get. When it comes to pipe, solder, flux, all these different compounds and valves and components we're talking about, they can only take so much heat. And the longer they're being susceptible to that heat, the more damage that's going to occur. So we got to be thinking, how are we going to protect it so we can have a successful repair that's going to last a long time and not cause potential safety issues down the road. So when it comes to the actual soldering process, I'm not going to cover this in great detail because I think it's already been covered in another lesson, but we got to do the fundamentals. I've already cut this pipe. We need to make sure to sand it, which I've done. We want to make sure to ream it, which I've done. So remember, reaming is going to remove the burr that's inside, that if it was there, it could cause turbulence and a potential leak down the road. So I'm going to go ahead and flux this. Flux is going to be critical. Flux is what is going to remove oxides. It's going to help the solder flow into the fitting and create that bond. And so we need this. And a seasoned technician one time told me that cleaning is the most crucial part, and that has really rung true for me over the years. So I'm going to get an even coat on this. And these brushes are notorious for the bristles falling out, so if that happens, just make sure to get the bristle out, and because we want this as clean as possible. So I got this fluxed, and before you head outside, let's just think about this. So This particular solder we're using, it's going to melt around 460 degrees. So the goal here is we're going to take the torch and we want to heat this fitting up as evenly as we can. Reason being, especially when you get into bigger size copper tubing, if you just held your flame on one spot, it could take a long time before the top of the fitting was heated up enough for the solder to melt. That would be bad. That could melt. That could actually burn the flux, which would result in it not removing oxides and the solder not flowing in and you not having a successful joint. So the best we can, we want to be moving the heat around. We want to be heating the fitting rather than the pipe because the solder is going to flow towards the heat. Okay? Once it is heated up enough, that is when we're going to actually apply the solder, and you should see it run around the fitting, and that's what you want to see. And then you're going to let it cool down, and you're going to clean it, you're going to check it. So let's head outside and let's complete this soldering project. Alright, so we're outside now getting ready to finish this project. So I got the bucket of water with rags in it, I got glasses on, I got some thicker gloves on, and just before we get going, a tip that I've learned, which I found helpful, is just to do a little bend at the end of your solder. It can be kind of hard starting out to know like how much solder you're adding as it's melting away, and somebody taught me this. So for a 1/2 inch pipe, if you do about a 1/2 inch bend, that's just a general rule how much solder is going to be needed for each side of the fitting. If you're using 3/4 inch copper, you'd bend that at 3/4. So the torch I have, it has a spark igniter on it, so we'll get it started and we'll get this soldered. So I'm going to light the torch with it pointing away from me. So I'm going to start heating up the fitting. I'm going to be moving this around the best I can, and then periodically I'm just going to, touch the solder to the copper just to see when it starts melting. Not quite there yet. Okay, so it's flowing now. I'm not keeping the torch directly underneath it. It's to the side a little bit because the solder will drip, and if it drips into the torch head, it's going to cause damage or at minimum embarrassment. Okay, got that off. Let me put the torch down. And I got an inspection mirror here. These are handy to have just to be looking around the fitting, making sure that the solder has went completely around, which it has. And so we're going to let this naturally cool. Before we start touching it and pulling stuff apart, we got to be careful because that solder is still melted. And if you start pulling on it, stuff could come apart and you could have a failed repair. The other thing we want to watch for is not to cool it super quick, because like a quick extreme drop in temperature could actually cause the joint to fracture, which would be an unsuccessful repair if it leaked. So we're going to let it cool a little bit. We'll use our wet rags to cool it down, and we'll wipe off any excess flux. And always make sure that you check your fitting visually, and after you, if you turn the water back on, make sure it's not leaking, because you don't want it to come apart or anything like that. Okay, cool it off. Wipe that, and that's it. So thank you for the opportunity to make this video.